This is 2.7 inverse functions. Now, inverse functions you've done in a prior class, but let me remind you what they are. Like a normal function takes x to y. Like literally you make an xy chart and you plug in numbers for x, and then you evaluate it, and then it takes it to y. It finds the y value once you know the x. So an inverse function basically goes backwards. So it basically takes the y to the x. So here's an example. So basically you have a function f of x equals x plus 1, and notice the xy chart. Well, notice the inverse function, and notice the notation. The notation is -1. I do want to comment, by the way, this does not mean, like normally back when you were covering Algebra 1, Algebra 2, a negative exponent means to flip. Okay, it takes the reciprocal of it. That is not the same thing here. Okay, so there's something you got to get wrap your brain around, where this is a mathematical operation where you're taking the reciprocal of it. This is just notation, and just get familiar with that. When it's referring to a function, it's the inverse function. So anyway, that's the notation of it. But notice the xy, it went from 0 to 1, but notice here I'm doing 1 to 0. And then this went 1 to 2, this is going 2 to 1. So basically, I'm swapping the x and y values. That's really what I'm doing. I'm literally taking all the y values and I'm putting them into the x, and that makes the inverse function. Again, the x and y's basically change positions. Okay? So this you can graph using y equals mx plus b. You know how to plot that. All you have to do is really just swap the x and y columns, and then you can start to sit here and plot those points and graph the inverse function. So that's one way you can always graph the inverse function. Just simply look at the xy chart of the original function, swap the x and y's, and then graph that new chart, and that's actually the inverse function. So look at an example here. So if I gave you this, and this is f of x right here. This is f of x. And what I want you to do is graph f negative of x, the inverse function. So you take each point. So here's the, let's do the original function in blue. So the original function f of x, again, the original function, let me graph that in blue. That's the original. And each point, if you make an xy chart, so I have -10, -1. I have -8, 2. I'm just plotting the points there, or writing the coordinates of the points. So -5, 1, -3, 0, and 0, 3. And then the inverse function, I'm going to basically take the x and y's, and I'm going to swap them. So look at the y column right here is -1, so I'm filling that with -1, and then that's going to be -10. And then 2, -8, 1, -5, 0, -3, and then 3, 0. And then you can graph those points on there to see what the inverse function would actually look like. All right, now a one-to-one function. Again, you've covered this definition prior, but to see if it's a one-to-one. A one-to-one, basically, when you make an XY chart, does every value uniquely go to its own value? So in other words, one in, one out is the definition of a function. So like 2 goes to 3, 4 might go to 9, 6 might go to 11. Each number goes to its own unique number. Okay, that's what one-to-one functions mean. So you could still have another function, by the way. This still might be a function. Let me give you an example of a function that's not one-to-one. So if I have 2 goes to 3, but I also have 4 goes to 3. Again, it is a function because with one number in goes one number out. See, that is a function. And this is one number goes in, one number comes out. So that is a function, but it's not a one-to-one. It's not unique. Every number uniquely goes to its own number. Now, an easy way to tell it, if you look at the graph, is a horizontal line test. So if you draw a horizontal line test, and if it crosses more than once, then it fails. So if it fails the test, there is no inverse function. It's got to actually pass the horizontal line test. So for instance, a parabola if you draw a horizontal line test, notice it crosses at 2 spots. So it is a function, a parabola is a function, but it's not one-to-one. Therefore, it does not have an inverse function. Matter of fact, if you took every point on that function and then you swap the x and y's, it would literally look something like this. And again, that's not a function, because when you draw the vertical line test, remember, to see if it's a vertical line, to see if it's a function, the vertical line test has to pass. And so that would not pass. That's why we know it's not an inverse. It doesn't have an inverse function. We're about to do that. So if it doesn't pass the horizontal line test, then the inverse function does not exist. All right, so how to actually find inverse function. Now, we just got done doing, like, hey, I'll just swap the x and y charts. Well, I want to know what the actual function is, though, not just how to swap the x and y charts. So how to find the inverse functions. Well, first of all, step number 1, use the horizontal line test to see if it actually has one. That's a very crucial step. Always do that first to see if it actually has an inverse. So if it has an inverse, then you can go ahead and find the inverse. And basically what we're going to do is swap the x and y's and then solve for y. Those are the 3 steps of how to find an inverse function. And then we're going to talk about ways to verify to see if it actually is an inverse. So let's first do the first part. So let's go to this problem. So notice it's f of x equals 5 minus 3x over 2. And what I want to do is a couple things. If you go back and look at this right here, use the horizontal line test. Well, if you actually remember, this is y equals, and if you want to write it like this, 5 halves minus 3 halves x. Now that's just a line, okay? That's just y equals mx plus b. And when you graph a line, when you graph this line, you will see that it does pass a vertical line test. So this is it is a function. Also, if you draw the horizontal line test, it only crosses at 1 spot, so it does have an inverse. So make sure it has an inverse. That's step number 1. Okay, step number 1: use the horizontal line test to see if it has, see if it passes. So it does have an inverse function. Now, what we're going to do is swap the x and y. So literally, this is the y. We're going to swap that to an x, and then swap that to a y. We're just going to swap the x and y. So remember, that's what an inverse function is, if the x and y's are going to swap. And then we're going to just use algebra to solve that equation. We're trying to solve for y. Okay, that's what we're trying to do. So we're going to minus 5 halves. Actually, there's nothing wrong with what I just did, minus 5 halves, minus 5 halves. There's nothing wrong with that. But what I would probably do on this problem, I'm going to back that up. There's nothing wrong with that. Because there's fractions involved, I'm just going to multiply everything by 2. So if I just multiply this by 2, multiply this by 2, multiply this by 2, it becomes 2x equals 5 minus 3y. Notice all of the fractions disappear. All right, and then we're going to solve for y. So we're going to minus 5 from both sides, and then divide by a negative 3. So I'm going to divide everything by a negative 3, so that's a negative 2/3 x plus 5/3. And then all we're going to do is swap this, because that's the inverse function. So this right here is the inverse function. Okay, so we're going to swap the x and y's, solve for y, and then if you notice the steps, that's what we're doing: swap x, y, and then we solve for y. So we found the inverse functions. Now, to check to see if it is a if it actually does exist, like what if we made a mistake? How to double check this? Well, one way to do it is we can look at the XY chart from this. So you can use your calculator or just make an XY chart. Make an XY chart, and then look at the XY chart from this one. And remember, what will be the difference between those? The x and y's will literally swap one another. So you can literally look at this XY chart and then look at this XY chart and then look and see if they're swapped. The x and y's are swapped. The other way to do it is do the composition of both ways. So you would literally, we just got done doing that lesson, so you would have to literally do f of g of x. In other words, plug g of x into f, and then likewise plug f into g. And if both of those work, like once you solve that, like plug G into F and F into G and you get X, you get that true state, then you're going to see that it is an inverse function of one another. So there's two ways to verify it, and that's how to do inverse functions.